Right, so this is one of the first things that we talked about, was taking a repeating or terminating decimal and rewriting it in its rational form as a fraction. Okay, so the first thing you need to do is recognize, are you dealing with terminating decimal or is it a repeating decimal? Okay, this first example terminates, means that it stops right here after this third digit, after the decimal. So what you're going to do to simplify this is you are going to write out all your digits, and you're going to divide by 10 to the power of however many digits came after the decimal. So there's 3 digits here. 10 to the power of 3 is 1,000. Okay, and so this would be your number. Okay, but then you'd have to go ahead and reduce this. And you are going to reduce it by hand, okay, which might be somewhat time-consuming as far as trying to find some factors, common factors that you can remove. What are some division rules that allow you to simplify this, and so that you don't just go by dividing by 2 every time?
I was going to say if it ends in 2 or a factor of 2, then.
Okay, so like you can always come back to the whole, like the even number, right? So you can divide by 2, but there should be some other things that you might notice. So here in this number here, if the last 2 digits is divisible by 4, the whole number is divisible by 4. Okay, 12, you see, is a common multiple of 4. So what that means is I can take a 4 out of each of these. So what would 4 out of 1,000 leave? Okay, 250. And then what I do from this is I divide 4 into each of these. And here's kind of how I would do sort of the longhand math division here, but kind of shortcut it. Okay, 4 goes into 5 how many times? Once, with how many remaining? 1. I'm going to write the remainder just in front of the next number. So now 4 goes into, so instead of having to drop that 7 down, I'm just going to write my remainder up above. So 4 goes into 17 how many times? 4 with what remaining? 1. So I'll write my 1 in front of the next digit. 4 goes into 13 how many times? 3 with how many remaining? 1. 4 goes into 11 how many times? 2 with how many remaining? 3. 4 goes into 32 how many times? Okay. So I know that I still can divide even further. Okay, what common factor goes into both of these? So does 4 go into 250? Okay, so now we know 2. So let's test 2. Okay, so we know that 2 goes in, so this becomes what in the denominator? Okay, and then we just divide 14 goes into, or 2 goes into 14, 7 with no remaining, 2 goes into 3 once with 1 remaining, goes into 12, 6 with no remaining, and goes into 8, 4. And so you wind up with this number. Okay, are there any common factors between these? Okay, so some of the tests that you should know, divisibility tests. Okay, so obviously the test for division by 5, right? That one's easy if it ends in a 5 or a 0. Okay, what about the test for division by 3? Did we talk about that one? If the sum of the digits is a number divisible by 3, then all the numbers are. So if I look up here, I have 6 plus 4 is 10, plus 1 and 7 is 18. So is this top number divisible by 3? Yeah, 18 is divisible by 3. So that might be one you check, but what happens when you look at the bottom? 5, 6, 7, 8. Is 8 divisible by 3? No. So you know you're not going to cancel common factors there. Okay, the divisibility rule of 9 is the same thing. Add up the digits, but see if it's divisible by 9. Okay, so again, would the top number be divisible by 9? Sum of the digits was 18. Is 18 divisible by 9? Yes. Okay, but not the bottom. Again, if it is divisible by 9, it's also going to be divisible by 3, which would make sense. Okay, division by 4, is the top number divisible by 4? Look at the last 2 digits. It would be. Is the bottom number divisible by 4? No, 25 is not. Okay. The only other one that, kind of has a division rule that you can use quickly and easily would be 11. For 11, if you have like alternate digits that are the same, like give you the same total sum, then the number is divisible by 11. So like if you took 121, alternate digits 1 and 1, is that equal to this digit? Yeah. If you had something like this, would this be divisible by 11? Look at the alternate digits. 1 plus 1 is 2. 2 plus 0 is 2. Are they the same number? Yeah, so that would be divisible by 11 as well. So that's the way that you can test for 11 quickly, is to just add up like all the even digits and all the odd digits. If they're the same sum, then the whole thing is. Regardless of that, this is your answer in the simplified form.